All right, this first question was taken from Eastern Cape province, Maths Trial Paper 1 in 2021. So this question 2 has this quadratic pattern, which is negative 16, then another negative 16, then we also have 12, negative 12, then negative 4, then blah, blah, blah. So on that note, the first question says, write down the next two terms of the pattern. So the next two terms of the pattern, the idea is to just find the first difference here. Finding the first difference, you're going to get 0 because when you subtract this number from this one, so term 2 minus term 1, you get 0, then you get 4, then you get 8, then you have to get 12 because this must be your linear that has the same common difference. So on that note, when you move to the right hand side to get this one, you just have to say this one plus that one. So when you do that, you'll get 8. So this 8 is the next term that was required. Now moving forward, determine the term of the pattern in the form Tn is equal to an squared, then plus Bn plus C. So here you just need to continue with your difference, then finding the second difference. Second difference is 4 minus 0, you get 4. 8 minus 4, you get 4, you get 4. So this 4 is a common difference. So you just need to remember now that when you're looking for A, B, and C, you just say, okay, the second difference is just going to be equal to 2A is equal to 4, which is equal to the second common difference. Then therefore to find B, you just need to take this one, which is 2A plus B is equal to the second the first difference, which is T1 minus T2 minus T1. Then therefore the first term is equal to A plus B plus C. So this is what you have. So you just need to use this whole thing and with these numbers to find the values of A, B, and C respectively. So if we have this kind of situation, then therefore we can always find the value of A is going to be, we have 2A is equal to 4, then your A is equal to just 2. Then coming to find the value of B, then you have 3A plus B is equal to 0 there. Then therefore we have 3 in the place of A, we put 2, then plus B is equal to 0, then our B is going to be equal to negative 6. Then coming to the last one, which is this one, we have A plus B plus C is equal to negative 16. Then our A is 2, then our B is negative 6, then our C is what we are looking for, then is equal to that. Then our C becomes just negative 12. So then our Tn is 2n squared minus 6n, then minus 12. So we are done calculating the value of Tn in this form. Now, coming to the next question. The next question says, determine the value of the 38th term. So the 38th term now is going to be calculated by taking this 38 and putting straight to your role. So we have 2 in the place of n, we put 38, then minus 6, then we have 38. We have 38 here, then minus 12, then we get the answer. Then 2 times 38 whole squared, then minus 6, don't forget the squared, ladies and gentlemen, then minus 12, then therefore we get 2648. So this is the term, which is the 38th term of that quadratic pattern. So we are done with that one. So coming to the next one, it says, determine which two consecutive terms of the pattern will have the difference of 400. Now we are looking for the consecutive terms. Remember, this term and these terms are the consecutive ones, and that they give us what? They give us 8 as a difference. So they are looking for something like that now you have this term and that term, then when you subtract them up, they give you this number, which is 400. So which are these terms that they are talking about? So we need to work out now finding which are those terms. So let me just clean up this one, and then so that we have enough space to write our solution for this question. Let us not forget what we have calculated already, because we are going to use especially the rule. We still need the rule especially for this question. So we have Tn is equal to 2n squared minus 6n then minus 12. This is our rule that we got. Now for determine for which two consecutive terms of the pattern will have the difference of 400. So remember, when you are having consecutive terms, if you have x, then the other one is x plus 1. Or if you have x minus 1, then you have to add 1, then therefore the second one is just x. So these terms, when they are consecutive, which means they have a difference of 1. So on that note, you can think of having t n, then you also have tn plus 1. So these terms are consecutive. So when you are subtracting them up, they are going to give you 400. So this is what they are looking up. They are looking for that. If you subtract this one from this one, you are going to get what? You are going to get 400. So, but the idea now is that this 400 is actually the difference, which is the difference of the quadratic pattern is what is the linear pattern, which is the first difference is what we are talking about for 400, not the second difference, because the second difference is common. So the first difference is the arithmetic sequence. So let's just quickly rewrite our pattern. That is negative 16, then minus 16, then minus 12, then minus 4. So let's find the first difference. The first difference is what? We have 0 here, we have 4 here, we have 8 here. So having this kind of situation, then you will see that yeah, of course the common difference is what is 4. So our d is equal to 4, especially when we're looking for the formula for the first difference, which is the linear pattern, which means it's dn plus c, then which is now equal to our d is 4, then 4n, then our c is just gonna be, c is always equal to t1 minus common difference. So which means our t1 is what? Our t1 is 0, then 0 minus our common difference, which is 4, is just going to be negative 4. So we are having that formula for the first difference. This is the formula for the first difference. So if that is the case, if this is the formula for the first difference and we are given the first difference, which is 400, we can just equate this first difference by 400 and look for the value of n. So minus 4 is equal to 400, then therefore our 4n is equal to 404. When we transpose this negative 4 that side, then our n becomes then 101. So we have that one. So our n is equal to 101, which means now we are having tn, and the other one is tn plus 1. Then therefore our tn is equal to, we have t101, then the other one is t101 plus 1, which is 102. So which means we are looking for t101 and t102. These are the terms that are consecutive to each other. So which means now in our general formula, which is this one now, because we have to go back to our quadratic pattern, because between which two consecutive terms of the pattern will have the difference of this, which means the pattern that they are talking about is the quadratic. But now, because they gave us the difference, that is why we have to calculate the formula for the difference and equate it to 400. This 400, we cannot equate this 400 to the actual general formula for the quadratic, because the quadratic itself is not the difference of itself. The difference of the quadratic is the linear, of which this is the linear that we have determined its equation. So now we have to substitute these 101 and 102 in our quadratic to find the actual values, the actual terms that have this difference in 400. So on that note, we have t 101, which is equal to 2 into 101, then all squared, then minus 6, then 101, then minus 12, then we get the actual value there. So the actual value there will be equal to, I'm substituting 101 in the place of n, ladies and gentlemen. 101, then 101 unikeza 19784, which is 19,784. Then therefore let's get a 102. Then 102 is going to give us what? It's going to give us 2184. Then I believe that these terms, when you subtract these terms, subtract this one from this one, which means you have 2184, then minus 19784, you are going to get 400, because this is the difference that must be obtained when you subtract these consecutive terms of quadratic pattern. So this is one way of doing it when you given that one. For 3 marks, yeah, I just wrote some more details about it. It's not necessarily that it is too long. It's not that long. It's just a matter of I was just writing everything so that it becomes clear. So I can also expose you to another formula or another way of dealing with this kind of a question. Because at the end of the day, these are the long questions that we need to also master them, because yeah, we just need to know everything if possible. Now, in as much as we know that we are having a t1, tn, then tn plus 1 minus tn is equal to 400. This is what we know, that we said tn plus 1, and this one, if it's tn, then therefore we know that to find the difference we have to say this term minus that term. Okay, so to get what? To get that 400. So we are going to do that now, but we are going to just obtain the formula, the actual formula for this quadratic pattern. So tn plus 1, tn plus 1, when tn was equal to 2n squared, then minus 6n, then minus 12. Then here you can see that in the place of n they just put plus 1, because now they are looking for the consecutive terms, the terms as shiyene ngo-1. So that is why now we have tn plus 1 minus tn, right? Yeah, which means the term which is before tn plus 1. So on that note, we are having in the place of n, here we are going to insert n plus 1. So what are we having? We have 2, then we have n plus 1, but remember that it is being squared, then minus 6. In the place of n we have n plus 1, then therefore minus 12. Then remember that we subtract this one, which is tn. Tn is just that one. So on that note, we subtract it by saying 2n squared minus 6n minus 12. Then therefore we know that all this thing is going to give us our difference of 400. Now let's just expand this one. Expanding this one is going to take us through 2n squared, then plus 4n, then plus 2, and then minus 6n, then minus 6, then minus 12. Done with this one. Then minus, then this one I'm going to distribute this negative term, negative number. Then we have minus 2n squared, then plus 6n, then plus 12, then this is equal to 400. So let's check if there are things that are cancelling out. This one cancel that one, then this one cancels this one, then also this one cancels that one, then also we have this one now, which is 4n, then this one and that one, they give us -4, then we have -4, which is now, yes, done with that one, then this is equal to 400. So you can see that this is that general formula, your second difference that we have calculated in the previous approach. So we are now having the very same thing. So we have 4n is equal to 404, then n is equal to 101. So we do the very same process here to find those consecutive terms by substituting by 101 and 102. So this is just how we can approach this question. I just gave you two different ways of doing them. I hope you understood them and perfectly, and thank you for watching this question number 1. See you right on the question number 2. Then 2.2, given the arithmetic series, which is 258 dot 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 up to the last term, which is 89, it is equal to k. So what is this k? You must know that this k is the sum of all these terms. Once you go to learner plus learner plus learner plus learner plus list plus this plus this plus this, they are going to give you the sum, which is whatever that is being equated to by these terms is the sum. So this k is just the same as the sum of all these terms that are being added from 2 to 89. Now we are having this one. The first question says determine the number of terms in the series. So finding the number of terms in the series, that means that a series is finite, and which means there is an end. There is an end number, which means we know the last term of that series. So to find the number of terms, which means we have 2, we have 5, we have 8, we have blah 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 blah, and then 89. So we need to just first find that the general rule. So we have 5 minus 2 is 3, 8 minus 5 is 3, then therefore all the way to 3. So the common difference is just 3. So the term Tn is equal to 3n, then 2 minus 3 is just -1. So finding the number of terms, we just need to know that Tn is equal to that last term. If the last term is given, just use it to in the place of what? Of Tn. So in the place of Tn, I put 89, which is the last term, and which means this one is the last term. So we have 3n, then plus 1. So we have then 90 is equal to 3n, then n is also going to be 90 divided by 3 is equal to 30. So we have 30 terms in this pattern from 2 to 89, which means there are 30 terms that are being added there. Now, the second question says determine the value of k, which means now you'll remember that the value of k is the sum of these numbers. So we just need to remember now the formula for the sum of arithmetic series. So the first one is n over 2, then we have a, we have 2a plus, then n minus 1, then times d. Then the second one is n over 2, then a plus L. So it depends here, what do you have? Are you able, can you use this one, can you use that one? But if just be flexible, otherwise you must just always choose the easiest one to use. So I always recommend this one when you have the first term and the last term. It's easier because you don't need to use this long one, and otherwise both of them, they can help you to find the very same thing, but it's always the best to use the easiest one for yourself. So in the place of n is 30, we just did calculate it. Then the value of a is 2, then the value of the last term is that one, which is 89. Then this is what we have. Then we have 15 into then 91. Then therefore punching this into a calculator, you will get 1365 5. So this is just what we have. This is the sum, or this is just the value of k there. So you can even just put k there, then k there, because this is just what was given initially. So this is what we have. I hope you did enjoy and understood what I just explained. See you in the next question. Thank you. All right, we are having question number 3 here. Says, given that in the geometric sequence T9 is equal to 768, term number 9 is equal to 768. Remember that the name of the sequence is given there, which is geometric. So T9 in geometric is represented by what? Is represented by AR to the power of 9 minus 1, which is going to be 8. Then it is equal to 768. Then therefore we also have term 13. Term 13 is given by AR to the power of 13 minus 1, which is just 12. So yona ilingana nabana 2288. So you can say this is equation number 1 and this one is equation number 2. So what do you do to find the value of A, the value of B? In a geometric pattern, you always use the elimination method by dividing the equation by another equation. So which means let's divide equation 2 by equation 1. Let's divide equation 2 by equation 1, which means now when you divide this equation by that equation, of course these two a's are going to cancel each other. Then you will be left with what? R to the power of 12 minus 8, which is just going to be 4. Then divide is equal to, then we have 12288 divided by 768. Then you will get, I don't have the mind to think about this. So you are going to get, yes, 16. Then when you have 16 here, you can apply fourth root to write the value of R there. So when you have fourth root, you just need to remember that you will have plus or minus 2. So you can probably forget about that plus or minus. You just need to know that when you are having a root of odd number, you will always get two values, which is the other one is negative and the other one is positive. So that is why we are having two values of R. The other one is -2 and the other one is +2. So remember the question that it was saying, determine the values of the common ratio and the first term of the sequence. So which means the values, which means now you are expecting two things or one thing, because this S means it could be 1, could be 2, but they just want to be safe when it comes to the number of values that we have found instead of the number of value that then they want. Now after having this R, which is equal to plus or minus 2, you can go back and calculate the value of A now. So calculating the value of A, we can use any of these two equations. So which means we are having A, then the place of R we can put 2 or -2, but I believe that we're going to get the same thing over there. So which means we are having A is equal to, so we have 768 divided by 2 to the power of 8. Then therefore our A becomes, when you press your calculator, you will get 3. So the value of A is equal to 3. Then I believe even if we are using R, which is -2, we are going to get the very same thing with that A is equal to 3, because -2 or all to the power of an odd number, it's always going to get to be positive. So that is why the value of A for both values of R, you are just getting what? You are just getting the very same value, because at the end of the day the sequence must just have the same value of R, of A. There has to be 3 just now. So I think that is all that I have for this question. See you in the next question. Thank you. The sum to infinity of a convergent geometric series is equal to 54/19. And the sum to infinity of the same series calculated from the third term is 24 over 19. So the question says calculate the sum of the first two terms of the series. Now we need to know that when they say the sum to infinity of the convergent geometric series is that they say we are having a over 1 minus r. This is the what? This is the formula for the sum to infinity. Okay, this one is equal to 54 over 19. Now, the sum to infinity of the same series calculated from the third term. So that means since you are having a, which is the first term, then ar, which is the second term, then ar squared, which is the third term, then ar to the power of 3, which is the fourth term. They are saying since this one is the third term, so the sum to infinity of the same series calculated from the third term is equal to that. So they mean that this series now, they calculate it from the third term, which means these ones are removed to get the sum of this second series, which is calculated from the third term, because now term 3 plus term 4 plus term 5 plus term 6 plus term 7 plus term 8. So this is just what we have for now. So that means they want us now to calculate the sum of the first two terms of the series. So what do? We do what? So which means we are having the sum to infinity, which is the sum of all terms in this convergent geometric series, then minus, right? Minus the terms, because now you are subtracting the terms sum to infinity, then from what? From the third term. From the third term. So which means now sum to infinity is equal to 54 over 19. So this is what we have, sum to infinity. This is this sum to infinity. Then subtract this term 3 plus term 4 plus term 5 plus term 6 plus term 7 to get the what? The first two, the sum of the first two terms, because now we are subtracting what? With term 3 plus term 4 plus term 5 plus term 6 plus term 6 up to infinity. So which means it's sum of the what? Of sum to infinity of the same series calculated from the third term is equal to that, right? So which means we are going to subtract that one, because this sum that I'm writing now is starting from term 3, term 4, term 5, which means now what is going to remain behind is going to be the remainder after you have subtracted term 3, the sum from term 3 up to infinity. Then therefore the first and second term is going to be remaining behind. So what are we having now? Oh, remember we have 4 here, then therefore it's going to be 30 over 19. So this is the sum of the first two terms, right? Because now you have a plus a square ar, then plus ar squared, and then plus ar cubed, then which means now the sum to infinity that starts from the third term is this one. So we are subtracting this one so that we get this remaining two terms. So we are getting the sum of these ones. So which is gonna be that 13 over 99. So this is what we have for now, which is equation number 3.1. Now moving to the next question. The next question says show that a is equal to 30 over that. Okay, so now we need to remember the fact that we are having term 1 plus term 2, which is equal to that 30 over over 19. That's what we got, because this is the first term and the second term. This is the sum of first and the second term, which is what we got up with first question. Okay, so this is a then AR. These are the first two terms that we got. So now let's try to solve A. We can just remove the common factor there. So we get 1 plus R then is equal to 30 over 19. So remember, we're looking for A, then therefore we can divide by what we are not looking for, which is going to be that one. So remember that when we divide by 8 algebraically, it's going to just stay there. So our A is now equal to 30 over 19 into 1 plus R. Yes, so this is what we have. So the idea was to note, okay, let's just write there the terms in what in this in terms of A and R, so that we figure out the value of A in terms of R. So this is what we have proven what was required there. So the next question says determine the value of R if R is greater than 0, which means now, because of this condition, we will probably get two or three values of R if possible, but now we need to take the one that is greater than 0 to be the what? To be the correct solution. So we really have to consider this conclusion at the end of our solution. So now what are we having? We are having this kind of situation. Then our R, how do we then determine the value of R? The value of R, we need to remember that we are having A over R minus A minus A 1 minus R, which is equal to what are we having? We have 54 over 19, which is the sum to infinity, which is given as 54 over 19. So this is what we have. So on that note, now we know that A way 2 is calculated to be this thing. So we can just substitute by our 30 over 19 into 1 plus R there in the place of what? In the place of A. So we have 30. So you need your algebra here, a little bit of algebra, then divided by R 1 minus R, then is equal to 54 over 19. So which means in the place of A, we substituted this thing because we have figured out the value of A in terms of R. Now let's move together. It's this one. This one is just gonna be we are going to have this kind of situation. Then this one is going to multiply there, which means we are having 19 divided by 19. We are going to have, okay, let's just show all the calculations. We have 19 here, and this 19 is going to multiply this 30, which means we have 19 there. Then times 1 plus R there, then is equal to, then therefore we have 54 into 1 minus R. So on that note, this 19 is going to cancel that 19. Then we end up having what? Having 30, and we can take this one all the way to that side, your multiplier pair. So we have 54, then times 1 minus R, then 1 plus R. So this is what we have so far. Then therefore we can simplify to say we have 54. Then this one is just a difference of two squares, ladies and gentlemen. That can just give us 1 minus R squared. Then therefore we have 30 here. We can just divide by 54 both sides. Divide by 54, divide by 54. Then we have 30 divided by 54 is just gonna be 5 over 9. Then therefore, which means we have 1 minus R squared. So if we take this one to the other side, we will get negative 4 over 9 is equal to negative R squared. Then therefore, when you divide by negative 1, then you get 4 over 9 is equal to R squared. then therefore you can find your r to by applying a square root both sides. Then you have plus or minus, then you have 2 over 3 is equal to r, which is plus or minus that. Then therefore your r is going to be 2 over 3. So we did manage to do what? To find r which is greater than what? Which is positive, which is greater than 0. So the idea was to use the information that you have, this a, and know that the value of sum to infinity is given as 54 over 19, then be able to deal with fractions, and we managed to get the value of r just like that. Otherwise, if you really need more of explanation, you can always rewind the video and listen again. Otherwise, see you in the next video. So this is Eastern Cape Maths 2.2 Exemplar 2021 Paper 1. So number pattern, we are having the first question says, determine which term of the sequence this is equal to negative 47. So when they say which term, which means they are looking for the value of n. And which term, which means in which position does this negative 47 occupy. So we need now to calculate the value of n. And you can just take this negative 47 as just your last term, because when you have the last term, you just treat it as a what? As a tn. So we are having tn here, which is equal to negative 47. So when you have tn, which means we have to find the general term, so that we look for the n, the value of n in your general term. So on that note, we are having this 23, then 21, then 19, then blah blah blah. So we can say negative 47 as our what? As our last term. Good. Now let's find the common difference. So 21 minus 23 is just negative 2. Then 19 minus 21 is just negative 2. So that means our difference is negative 2. So we are having this tn, which is equal to negative 2n, then plus our constant, which is the constant is term 1 minus the common difference, which means c is always term 1 minus the common difference. So which means now what is 23 minus negative 2 is just going to be positive 25. So on that note, in this general formula, we need to put in the place of tn, we put negative 47, then we have negative 47 there, which is equal to negative 2n plus 25. Then therefore we take this one to this side, then we will be having, then it's going to be negative 72, which is equal to negative 2n, then our n is going to be equal to 36. So which means now when they say which term, which means it's term 36 that is equal to 47, which means we have term 1, we have term 2, we have term 3, we have term 4, we have term 36, which is equal to negative 47. So we are done with that one. Let's go to the next question. Then the next question says, let me just quickly wrap this whole thing. Now, the second question says, the first three terms of the arithmetic sequence are, this is the first one, this is the second one, this is the third one. So we have 3 terms of the arithmetic series, and you can see that there is an unknown, which is the value of x that we are to figure it out. So the first question says, calculate the value of x. So it is very important that when you are having x as an unknown, they have to give you the name of the sequence that you are dealing with. Otherwise, without having the name of the sequence, there must be another information to be provided. Now let's have this pattern, which is 3x minus 1, then the second one is x plus 5, then the third one is 2x minus 4. So when you are having the arithmetic sequence, we just need to remember that the arithmetic sequence has the first common difference that is common. So when we are having this one, we're just gonna find the common difference, which means this term is going to be equal to that term right from the scratch. Now, what are we having? How do we find this number? We say term 2 minus term 1. So we have term 2, which is x plus 5, minus term 1. We need to always insert the bracket so that the whole thing becomes subtracted. So we are having that one. So which is term 2 minus term 1. So this is what we have. Then therefore we know that term 2 minus term 1 is equal to term 3 minus term 2 if the pattern you're dealing with is only an arithmetic sequence. So now, which means term 3 must be equal to term 2 subtract term 3 from term, subtract term 2 from term 3, which means you have term 3 minus term 2. Then you open the brackets when you subtract the binomial terms. So we are having this one. So we can now simplify so that we have x plus 5, then we have minus 3x, then negative and negative is plus 1, then is equal to, we have 2x minus 4, then you have minus x minus 5. So moving forward, we are going to have, what is x minus 3x? It's minus 2x. Then if we can take this x, this 2x, and this x, 2x minus x is just x. So if you can just take this x here and put it here, then therefore we continue. Then you take everything on the right. Then you have minus 4, minus 5, then minus 1 as well, minus 1. So we have minus 3x on this side. Then therefore we have minus what? All right. Then we have minus what? Oh, remember, I did not put this one. We have this and that, which is negative, which is negative 2. Then this one that is equal to negative is equal to plus 6, right? So we have 6 there. So on that note, if we take this 6 to the other side, it becomes, we have negative 4, then minus 6, minus 5, then minus 6, then you'll end up having 3x is equal to minus 15. Then if you can divide both sides by negative 3, you'll get just positive 5. So the value of x is now positive 5, and sorry for that mistake. So that is what we have. We managed to get x being equal to 5. Then the rest of the questions, now we need to use that 5 to get the numerical values of these terms. Okay, so if x is 5, then 3 times 5 is 15. 15 minus 1 is 14. The first term is 14. Then if x is equal to 5, then the second term is going to be 10, because 5 plus 5 is 10. Then the third term, if x is 5, 2 times 5 is just going to be 10. Then 10 minus 4 is equal to 6. So the third one is equal to 6. So you can see now that the common difference is 4, which is negative 4. So that is just what we have. So the question now says, determine the number of terms which the sum is equal to 0. So the number of terms with the sum is equal to 0. So we are having, first of all, we are having these terms, which is 14, which is 10, which is 6. Okay, which is 14 plus 10 plus 6. Then of course it's gonna be plus 2. Then continue that way. Now we know that the common difference is just going to be negative 4, negative 4, negative 4. Now we try to determine the number of terms in which the sum of the pattern is equal to 0. So on that note, we need to remember the sum. The sum, especially if you don't have the last term we definitely don't know the number of terms, but we know that when we add them up, they are going to give us 0, because they're saying the sum is equal to 0. So we have the sum, which is the formula, which says n over 2, then we have 2a plus, then n minus 1, then times d. So we are having this formula, so we can just substitute in the place of Sn, because they say the sum is equal to 0. Then in the place of sum we put 0. Then in the place of n, this is what we are looking for. Then in the place of a, yes, in the place of a, the a is the first term, so we put what, 14 there, then plus, then n minus 1, then our d is just -4. If I can just put times -4 there. So this is what we have. The idea is to solve for n now. So I can only multiply by 2 so that I get rid of this, cancel that, then therefore we'll be left with 0 on the right hand side. Simple for now. Then therefore we continue with the inner function that we have 2 times 14, which is just going to give us 28. Then therefore we have minus 4n, then plus 4 when we expand this one. Then therefore we have that. Now distributing this n inside, then you have 28n, then minus 4n squared, then plus 4n. Then on that note, we can always add things over here. That 28 plus 4 is always going to give us 32. Then we have 32n minus 4n squared is equal to 0. So we can now take out the common factor, which is n, which is 4n. Let's just say take out 4n. When you take out 4n, we'll be having that 8 minus n is equal to 0. Then the 4n is equal to 0, or 8 minus n is equal to 0. Then therefore here n is equal to 0, then n here is equal to 8. So that means n can never be equal to 0. You cannot add 0 terms to get yeah, it's possible, but in this case when you add them up here, they have to give you 0. So how many of those terms that you are going to add, how many terms of those terms are going to give you 0? So there are 8 terms that are required here. Yeah, but I can take this one as well. I can take this one because when you add 0 terms, but they said determine the number of terms which the sum is equal to 0. So I can take this one as well to be a solution, because they did not say determine the number of terms of which the sum of this pattern, and but it's reasonable for this one, because when you add this number of terms, you are going to get 0, because now you remember you are adding nothing. So but there's a debate around this. If there's a problem or anything that you notice, you can just comment down below. So on that note, I think for this question I'm done with 2.2.2. See you in the next question shortly. Bye. Okay, question number 2.4. It says calculate the value of a, which is this one, if the sum of all this thing is equal to 28. The fact that there is this sigma, you must know that this is the sum of this thing, which means Sn of a number of terms is equal to 28. So the sum is 28. So then you may be interested in knowing the number of terms that we have in this series. So the idea is that this number is the number on top and this one is the number on the bottom. Now what are we having? To find the number of terms, you say number of terms, which is n, is equal to number on top minus number below, right? So which means we have this one. So that means we have n is equal to number on top minus number on the bottom, then therefore we always plus 1. So this is the formula that we use to find the number of terms. Otherwise, if k start from 1 and we have 3 there, that 3 becomes just the number of terms. Otherwise, it depends ukuthi siqalephi dibanisa okanye to add these numbers. When did you start? Did you start from the first term that will make this number to be the actual number of terms, or we did not insert the first term, we just started from term 2, that will make this one to be not to be the number of terms, because now if we start from 2 to 3, which means we'll be having 2 terms to add. But if we start from 1, which means we'll be having 3 terms to add, which means term 1, term 2, term 3. But if we start from second term, which means we are going to add second term and the third term, which means only 2 terms that will be added. So to know the number of terms, it depends what is the starting point, what is the number on this below sigma notation. So this is the formula that we use to find the actual value of n, especially if this is complicated, because k can start from -1, k can start from 1, k can start from 7. It depends. So you just need to note, okay, it's the number on top minus the number below, then therefore plus 1. So it's always the case. So now to find the number of terms there, you just say the number on top is 3, then minus the number below is 1, then therefore there is always plus 1. So that is why we will get the actual number of terms, which is just 3, because k started from term 1, which means from first position. There is no term that is being omitted. So we have that situation. So moving to calculate the value of a. Now finding the value of a, we just need to find the first 3 terms. It's very important when you are given the sigma notation with the rule. We need to first find the first 3 terms of the series given, so that we are able to work it out. But remember, now what are we having? If we have a, then times 2, then in the place of k we'll put this 1, because k start from 1. Then when we put 1 here, we'll be having 1 minus 1, which is just 0. So 2 to the power of 0 is just going to be 1. So 2 times 1 is just a, just like that. So this is the first term. Then the second term is when k is equal to 2. So when k is equal to 2, which means we have a times 2 to the power of, in the place of k we put 2, then 2 minus 1 is just 1. So you will end up having just 2 there, which is the same as just what? 2a, then therefore plus. The third one is just going to be a, then times. We have 2, then in the place of k we are going to put 3, because we put 1 here, we put 2 here, then here we are going to put 3. So in the place of k, if we put 3, we'll be having 2, which is 3 minus 1, which is just 2. So you will end up having this kind of thing, which is 4a, because 2 squared is just 4. So we have this kind of situation. So you can see that since we said the number of terms are just 3, so this is just a manageable number that we can add a nalena to get what? 28, which means if we add all these 3 terms, you get 28. So we can actually get now the actual number of a by adding all these things. So 3 plus we have 6, then 7. So which means we are having 7a is equal to 28. So actual number of a is going to be 28 divided by 7 is just going to be 4. So the value of a is just 4. So this is what we have. So we can always now write down our formula, our series in numerical values. So in the place of a, I put 4, then we have 4, then plus 8, then plus 16. So this is what we have. So this all give us what? 28. This is term 1, term 2, term number 3. So to get to 28. So this is how we approach this sigma notation. So the first thing is to find the first 3 terms by substituting from k being equal to 1, k being equal to 2, then k being equal to 3. It's not always the case that you substitute until you get into this higher number. It depends, but first three numbers is the hint, or is the way of approaching a question that includes sigma notation. Otherwise, for that matter, see you in the next question. Thank you. Right, let's read this question. A circular disc of radius r is cut out of paper as shown in the diagram below. So this is the what? The disc that we are talking about, that is cut out, and it has a radius of r, which means from here to here we move r units, and from here to here we move r units. So this is what we have. Then two discs of radius half r are cut out of paper and placed on top of the first disc, which means now on top of the first disc as shown, which means we are having these ones, because it had two discs, which means we're talking about that one and also these ones. So they are put on top of the first disc, which is the biggest one, so as shown in the diagram. So these ones, they have the radius of 1/2 of 1/2 r, which means the radius of the first one, of the first disc, which is this one, is divided by 2 to get the radius of the second discs. So which means from here to here you moved r over 2, which is 1/2 r. Okay, then that means we are having four discs of radius 1/4 r are cut out of paper and placed on top of the two discs. So which means these ones, they are cut off, which means this is the first disc, this is the second disc that they're talking about. Then therefore the four discs, which means the first disc, the second disc, the third disc, the fourth disc, they are cut out and placed on top of this disc and that disc, which means these two discs. So, and these ones, they have the radius of 1/4, which means now we have 1/4 r, which means this is the radius of the small circle. Now that is what we have. So you can talk about, you can say this one is for level 1, hence they told us that this is level 1, the biggest one. Then level 2 is the brown one. Then the level 3 is the white one again. Then we can talk about level 4, because we can see that this pattern is continuing. Now, if the process can be repeated, which means now when we repeat the process, we are going to apply the very same thing from the biggest circle or disc to other discs that are going to be placed on top of the existing discs. So on that note, we can just think of having a disc enjani ezoma kanje, and we also have that one, and also have this one and that one, and this one and that, and this one and that one, and this one and that one. It makes sense because now you can see that each disc is having two discs that are placed on top of each. Okay, so which means now this disc is going to have two of them, this disc is going to have two of them, this disc is going to have two of them, etc. So now they want to say if this pattern continues, hence you can see that it's possible for it to continue this way, then determine the area of the discs of the fourth level only. So which means this one is the third level, then therefore these ones, these small ones that I just drew here, they belongs on the fourth level. Okay, so which means now we need to find the area of them, which means the total area of those discs. Okay, now we just need to find out the way, because now what are we having? The idea is that if the biggest the biggest circle is having a radius engubani engu r, which means the area of it is gonna be what? It's gonna be pi r squared. So that is the area of the first level. Okay, so the area of the first level is that. Then the area of the second level is these brownish discs that we have two of them, and each has the radius of half r. So which means now the area of the second one, since we have two discs, which means we'll be having 2 times pi, then our r is 1/2, then r, but let's not forget to square it. So this one is the second level. Okay, so because we have two of them, that is why we say 2 times pi r squared, and r is half r on its own. So you just need a little bit of analysis. So that is what we have. So this is the second level. Remember, we're going to fourth level. So third level are these whitish discs that are inside or that are on top of this brownish one. And how many of them? We've got 4 of them. So we can just say we have 4, then pi, then our r, the r of this whitish one is 1/4r, which means we have 1/4 r squared. So this is what? This is the third level. Okay, this is third level. So fourth level, we know that fourth level is going to be these 8 small balls there. Okay, these 8 small balls there. So which means we have 8, then pi, then our r, oh sorry, we have r here, then we have squared there. So our r here, you can see that here we didn't have any half, then if you have half here, we have 1/4. Here you'll be having 1/8, because you can see that each and every term that we get, we multiply by half to get another thing. So it's going to be 1/8, then pi, okay, pi, then r squared. So we have that kind of situation. Okay, then moving forward, then we are having, this is the fourth, this is the fourth, this is the fourth, which is what? The fourth level. So that means we are going to deal with this one. We can simplify it further, that 8 pi times 1/64, then r squared, then therefore 8 divided by that is going to be what? This is just going to be pi/8, then r squared. So this is the area of the fourth level only. This is the area of the fourth level only, because they did not say let's find the total area of 4 levels. So they just say the area of the disk that are on the fourth level only. So which means this is the area of all these ones, from then this 1 plus 2 3 4 5 6 7 8. So this is the area of the what? Of the fourth level, that has 8 discs that are placed in each of the white ball each. All right, then let's move to the next one. The next one says calculate the total area of all the discs, okay, if the process is repeated indefinitely. So we need now to calculate the area of all the discs. So now we just need to create a pattern on what we have just did. Sends a pattern so that says, okay, when they say the total area of all the discs, if the process is repeated indefinitely, which means now you can think of the sum 2 infinity, because you can see that now if you have 1 there, you have 1 over 2 here, you have 1 over 4, you have 1 over 8, you'll be having 1 over 16, 1 over 32, 1 over 64, then 1 over 128. So all those things, you can see that it's just the multiplication of 1 over 2 as what, as your r, which means this is a convergence series. This is a convergence series that we can also find sum to infinity. So which means now sum to infinity, when they say indefinitely, which means yeah, but we don't know when it's end, which means we can place this disk up to until Jesus comes back. So this is what we have. Then we have a over 1 minus r, where r can never be equal to 1. So on that note, the value of a is going to be the very first area which we got of the biggest circle or disk, which is pi r squared. So this is our first term. If we can say this is term 1, this is term 2, this is term 3, this is term 4. So our pi r squared is the very first term which will belong to the place of a. So now what we have a, which is what, pi r squared divided by 1 minus our r. Ladies and gentlemen, you can see that our r, which is our ratio, is just gonna be 1 over 2. Our r is gonna be just 1 over 2. Then the answer is gonna be 1 over it's pi r squared, then divided by just we have 1 over 2. Yes, then therefore this is just gonna be 2 pi r squared. So this is just gonna be what, the total area of all disks, the total area of all disks if the process is repeated indefinitely. Okay, so which means now we need to find the first term and all those things. So this is just what we have. This is just what we have. We just had to apply the formula for sum to infinity so that we find the equivalent area for all the areas of these kind of things. Okay, so that is just what we have. So which means they all add up to 2 pi r squared. So this is what we have for this question. I hope you enjoyed and you understood all this analysis that I've unpacked to you. And it was not easy, but just be careful. These questions will always be there. Probably one of them or two of them, they will always be there to check, or to check your ability in application of the topics of this kind. So thank you guys. See you in the next question. All right, so question number 2, we are having this question which says the pth term of the first difference of the quadratic sequence is given by this general formula. And you can see that this general formula, they are saying it's a first difference of what, of a quadratic sequence, which means it's not the actual sequence that we are dealing with, but it's the first difference, which means when you subtract t1 from t2 minus t1 and t3 minus t2, you will get something that is going to give you the formula of this sequence. All right, now which means now let's say we have t1, then we have t2, then we have t3, then you have t4. These are the terms for the quadratic sequence. So when you subtract to find the difference between these consecutive terms, you will then find the terms that are going to give you this formula, which means now you are having the first difference, which is this one, which is the first difference, which is this one, which is the very same thing that we have depending on the what, on the value of p when it comes to the number of positions. Now what are we having? We just need to remember that this is just all what we have. Let's come to the question. Determine between which two consecutive terms of the quadratic sequence the first difference is equal to 1450. Let me repeat the question. Between which two consecutive terms which means they are looking for the values of n, which means the positions, the consecutive positions where the first difference of the first difference of those two terms will give us 1450 between which two consecutive terms, which means we are looking for these positions, which positions are going to give us the difference of what, of 1450. So now when you talk about the difference, just remember what was given there, which means TP, which is 3P minus 2, because this is the formula for the difference of what, of this quadratic sequence over there. So now when they say this is a difference and this is a difference, which means these things must be equal to each other because they are the difference of the same quadratic equation sequence. So on that note, this must be equal to this difference that we have in a formula there. So we are having 145 0 is equal to 3p minus 2. So we have this one. So we can quickly find out the value of p now. Finding the value of p, which means we are going to have 145 2 is equal to just 3p. So when we divide that 145 divided by 3, you will just get what, p being equal to what, 484, right? So this is what we have. So we haven't answered the question now because they want two consecutive terms. This one, we can say that we are having probably, this one is what is let's say we have 4 or 8 8 4. This one is the number of terms. So which means now we for this one, if this is 484, which means we are having 485 4 8. This is the position of 4 8 5 then minus the position of 4 8 4. We just need to just plus 1 here because we have n and the other one is n plus 1, which means this one is n. Let's just forget about being given p by now, but now we just know that the position is represented by n. So which means this one is n, then this one is n plus 1, which means n that we got now, or p, then n p plus 1, n that we got is 484, then the other one, which is n plus 1, is what, is 485. So these are the consecutive terms that they are going to give us what, the difference of what, of what, of 1450. Yeah, and you will understand that these are not the actual terms, ne? So they are looking for the what, the consecutive terms, right, of the quadratic, between which two consecutive terms, ne? Which means they are looking for, it's term number what and term number what that they are going to give us this difference, not the actual terms for what, for a quadratic sequence, because now for us to find the actual terms for quadratic sequence, we will need to find what, we need to have this equation of this kind to substitute n being equal to 484, then n being equal to 485. But now they are just looking for what, for the positions, and for which two consecutive terms, ne? Which means they are looking for the value of n. So we are done for this one. Let's just continue with the second question. The second question says, the second question says, let me just wrap everything so that we clear up the space. The 40th term of the quadratic sequence is equal to 2219, and this general term is the general term of a quadratic sequence. So then calculate the value of c. Then you can see that we have 4 marks there. So how do we go about doing this? You can pause the video and try it, and then therefore you come back for the solution. So we have okay, the 40th term of the quadratic sequence is given by this and all else that is given. So how do we approach this one? The idea is to know that when you have the 40th term, that 40 is going to be used. But nonetheless, we can actually try to find A, B, and C. Because now remember, we have T1, we have also T2, we have also T3, we have also T4. Yes, we can continue up to T, and then we have T5. So if this is a quadratic pattern, then therefore we can look for the linear pattern that we already have. It's what? It's equation. So now let's find this term which is going to stay there, and you will see now P is going to be equal to 1 there, P is going to be equal to 2 there, then P is going to be equal to 3, P is going to be equal to 4. So that means we are looking for what number that is going to be here when P is equal to 1. So P is equal to 1, let's say P is equal to 1. Then what are we going to do? We are going to substitute it here. Then 3 times 1 is 3. 3 minus 2 is just 1. So the first term is just 1. The first difference is just 1. Now, let's find the second one, which means when P is equal to 2. When P is equal to 2, we get 6 minus 2, which is just what? Which is just 4. Then let's find another one. When P is equal to 3, then we have 9 minus 2, which is going to be 7. So you can continue and you will see that we get probably 10 there, because we're going to be having 12 minus 2, which is just 10. So we have these kind of things, and we can even continue finding the second difference. Let's just rub these ones, finding the second difference, and the second difference is going to help us to find the value of A, the value of B, and probably the value of C. Now we have 4 minus 1, which is 3, 7 minus 4, which is 3, then 10 minus 7 is equal to 3. So that means we can be able to find our A that way, because now we managed to do it, to say 4 minus 1, which is 3. So our A now, A is equal to 3 3 over 2, which means now we remember that we have 2A is equal to the second difference, then our A is going to be equal to 3 over 2. Then for our B, which is 3A plus B, is equal to that one, which means you are using this kind of situation. Then 3, then into 3 over 2, then plus B is equal to 1. Then therefore we are having B is equal to, then what is 1 minus 9 over 2? The 1 minus 9 over 2 is giving us negative 7 over 2. Then we can talk about what you call the value C now. Then after having that, we have Tn is equal to, our A is 3 over 2n squared, then B is 7 over 2n, then therefore plus C. Okay, now having that, because remember we cannot be able to use A plus B plus C, because we really don't have the first term of what, of our quadratic equation, our quadratic sequence. So now I think it's time now to use the information that was given, that UT40, or the 40th term, is equal to 2290. So let's just use it in this formula. In the place of Tn, we are going to put 2290, and then therefore we have 2290. Then the place of n, we will put 40, which means we have something of this kind. Okay, then therefore we are to find C now. Then therefore our C will become, let's just press all this into our calculator, then minus 3 over 2, 3 over 2, then plus 4 times 40 squared, then minus 7 over, it's going to be plus, then plus 7 over 2, then times 40, then we also have is equal to, then C is equal to 30. So finding C, which means we have transposed everything to the right hand side, then therefore we found C being equal to 40. So this is basically that. So I think that was the answer. The idea was to first find A, B, and we could see that C, we couldn't find C because we didn't have the first term of the quadratic sequence. Otherwise, we managed to get everything else because the first difference formula was given. So we managed to get everything else, but the quadratic was really difficult to work with it. We just had to use the first difference formula, which is that linear that was given there, to generate the second constant difference, so that you are able to find our A and our B. So this is basically that we just did for this question. See you in the next question. Thank you, guys. All right, everyone, if you really want to try this one, you can pause the video and come back for the solution. Yeah, moving on, we are having 3.2 says an arithmetic and geometric, which means we have two sequences here, have the same first term, which is equal to 5, which means the arithmetic sequence and the geometric sequence, they have the very first term, which is 5. Then this one is also 5. Good. So the first term is the same. Then the common difference and the common ratio have the same value as well. Okay. So now we just know that if that is the case, we can just say they both have K, R is K, then even D is also K. So to find the second term here in the arithmetic sequence, we always say the first term plus the difference, which means we have 5 plus K. Then even here to find the second term, you always say 5, which is the first term, times the common ratio. So we can have these ones. We can continue writing more other terms using this idea, but nonetheless we have all this. Now coming to the next statement, it says the fifth term of the geometric sequence is equal to 80. So, which means the fifth term, when you are writing the fifth term, we know that T5 in geometric, where it is represented by then AR to the power of 5 minus 1, which is just 4. Now, then they say fifth term is equal to that. So, which means when they gave you 18, then in the place of fifth term, you'll write 18. Then in the place of A, remember you do have A. In the place of R, remember that we just have K there, but K squared anyway. Now K to the fourth, right? So moving on by solving the value of K, which is which acts as a common ratio or the common difference because they share the same thing. So when you divide by 580, then you get 16 is equal to K to the power of 4. So let's solve for K. Let's apply fourth root upper. Then you will get plus or minus 2 is equal to K. So once we have that, let's go to our last statement. Determine the first three terms of the arithmetic sequences or sequence. So you can respect that S because that X means a lot. which means you'll be having two arithmetic sequences now, or one, because that s is it doesn't mean that we are having two arithmetic sequence. They say we might have more than one arithmetic sequences, so we need now to take note of things. We need not to throw other things away because of we did not understand the condition. The condition says determine the first three terms of the arithmetic sequence or sequences. Now let's determine them, because now this is our arithmetic sequence way of dealing with. Now we are having the first term is 5, of course. If k is equal to, okay, if d is equal to, yes, let's use 2 for now, because we have plus or minus 2. We can just use k being equal to d now, because we can see that the question is mostly focusing on arithmetic now. It completely forgot about the geometric. Now the question is about arithmetic. Let's just change that k to be d. Good. Now what are we having? We have 5, then we have 5 plus 2, which is 7, then we have 7 plus 2, which is gonna be 9. So this is what we have for the first three terms of the first arithmetic sequence. And you can see that our d is plus or minus 2, so we can have d, which is equal to -2, to get another sequence for arithmetic. So if that is the case, but the first one is always 5, because this is what was given, that the first term is equal to 5. Then for the second term, we are going to add -2 from this 5, then to find 3. Then when you add -2 from 3, you will get 1. So these are the other first three terms of these arithmetic sequences that we asked about. So it was only that to use the geometric and arithmetic at the same time, just to know how do these things communicate together to form particular reasoning way of dealing with both of them. So this is the combination of two sequences that we required to solve them. Otherwise, see you in the next one. All right, we are having this question. If you really want to try it, you can pause the video, then come up later. Otherwise, we are having this one. In a given arithmetic series, the first term is equal to 2, which means let's write down what is given. A is equal to 2, right? Where then the last term is equal to 29. Then last term is equal to 29. Then, and the sum of all terms is equal to that, which means Sn is equal to 155. So we have this information now. Then the question says calculate the common difference, which means we are looking for common difference. Now we need to use the information that we have, but how? The idea is that we are having the sum there and the first term and the last term, so it takes us through a formula of a sum of a arithmetic sequence when you are having the first term and the last term, that it is given by Sn is equal to n over 2. Then we have A plus L. This formula is very useful, especially when we have the first term and the last term. Now you can see that 155 was given as the sum of all these terms, and you don't know how many are they. That is why in the place of n we still have n. So in the place of A we put 2, in the place of L we put 29. Then therefore we are solving, then multiply by 2, then therefore 155, then it's gonna be what? It's gonna be, yes, it's gonna be 130. 155 plus times what? Times 2, which is it's gonna be 310. So 3 10 is equal to, then you have n times, then it's 31, because 2 plus 29 is 31. Then therefore when you divide by 31 both sides, you'll get n being equal to 10. So we haven't answered the question, but we know that if the first term is 2 and the last term is 29, then therefore we have 10 terms that are in that series. So on that note, we are looking for the common difference. So let's take this Tn, which is equal to a plus then n minus 1 times d, so that what we are using will be having d in it, so that we solve that unknown. So remember that L is the same as Tn, so which means now in the place of L and in the place of n, we're going to put 10. So in the place of L, we put 29, then blah is equal to, then the place of A, we put 2, of course, then the place of n, we put 10, which means we'll be having 10 minus 9 minus 1, then therefore times d. Then we continue solving, then therefore we have 30, we have 27. When you subtract 2 from 29, then therefore we have is equal to, then we just have 9 times d. Then when you divide by 9 both sides, you will get d being equal to just 3. So on that note, we managed to find the common difference for 4 marks. I believe probably there is another way of doing it, but nonetheless, enjoy the rest of the video, and see you in the next question. Right, when you are given a question like this, they say calculate, and they give you this sigma notation with a lot of information in it. So how do you go about dealing or unpacking this question? So the idea is to first be interested in knowing the number of terms higher. So knowing the number of terms is going to help you now to go about calculating what is required here. So how do you find the number of terms when there is this thing given? So number of terms, which is n, is equal to this number, which is 14, then minus the bottom number, which is 3, then there is always plus 1. So when you have that n, which is going to be 12 now, that is the number of terms that are being added to get this sum, because now this is the sum, but it is just shown in sigma notation form. So what do you do next after knowing the number of terms that are added in this sigma notation? So you just need to find the first 3 terms of this sigma notation. It's very important to find the first 3 terms, because that's the one that is going to give you more of information, like the value of a, which is the first term, the common difference, which is, of course, you can find out the common difference here is just -4, but there is a lot that you can find after having the first 3 terms. The idea is to find the first 3 terms. Then how do you go about finding them? The first term, you substitute by this 3 in the place of p there, then you get the first term. So what do you have? You have 15, then minus 4 times 3, then therefore you find the first term. So the first term becomes 15 minus 12, which is going to be just 3. Then therefore substituting by 4 now, because we have to go up by 1 unit more. Now we have 15 minus 4 times, we put 4 now because it started with 3, then we have 4, then we put 5, right? So 15 minus 16 now is going to be -1. So this is the second term, which is -1. So from there, let's find the last one, which is the third term, because we want to find the first 3 terms. So we have -4 times, then we put 5 here. So you can see that we have 15 minus 20, which is just going to be -5. So these are the first 3 terms, 1, 2, 3, the first 3 terms that we really need to have in order for us to go about finding more other things. So After having this one, we know that the common difference is going to be -4 because you have to say term 2 minus term 1. We get this common difference. Now we are looking for the sum of these things, right? And we can also be able to find the last term. How to find the last term? We are going to put 14 in the place of p. So which means now we are going to be having 15 minus 4 in the place of p. We put 14. Okay, so we put 14 so that we get the last term. So the last term here, which means we're going to be having dot dot dot, then therefore the last term is 15 minus 4 times 14, then we get negative 41. So we get negative 41. That's the last term. Now what do we do next? We need now to apply the sum formula for arithmetic series. So the sum is sum of the number of terms is equal to n over 2. Then therefore, imagine when you have the first term and the last term, it's very easy to use this sophisticated formula, which is a plus L. So we are having that one. If you have the first term and the last term, you can always use this simple formula. Otherwise, another formula for the arithmetic series is n over 2. Then we have 2a plus, then n minus 1 times d. So this is another one. If you have the value of d, which is the common difference, and everything else is there. So otherwise, both of these formulas, they work together the same way. Now, we are looking for the sum of how many terms we calculated the number of terms, which that it's 12. So sum of 12 terms. Then in the place of n, we just put 12. Then in the place of a, now a is the first term. Then we put 3. Then in the place of the last term, we put negative 41. Then therefore, whatever that we get there is going to be the sum, or it's going to be the answer for this one. Because when they say calculate and they give you something of this kind, you just need to know that you are calculating the value of n, unless again the sum, unless they have stated other information. Then when you press the calculator, this one, let's see what is it gonna be. Then we have 6 times 3 minus 41. Then therefore we have negative 228. So this is the sum of these terms. When you add them up, you get that. So that means this whole thing over here is just equal to negative 228. So we did evaluate, or we did calculate the sum of that. So this is how we approach sigma notation things to calculate the sum if it's given that way. So see you in the next question. All right, let's talk about this question. If you really want to try it, you can pause the video, then come back for the solution. So 2.4 says, the first term of the geometric series is 9. And the ratio of the sum of the first 8 terms to the sum of the first 4 terms is given by 97 over 81. So that's the ratio. Calculate the first 3 terms of the series sequence if it is given that all the terms are positive. Now, we know that we are having the value of a, which is equal to 9. And we are also given that the ratio of the sum of the first 8 terms, which means the sum of the first 8 terms, is to the ratio of the what? The sum of the first 4 terms, which means is to S4. It is given by 97 is to 81. So we're just writing the ratios of these things. Now, we know that sum of 8 terms can be represented by a into, then we have r to the power of n, which is 8, then minus 1, which is the formula, then divided by r minus 1. Then, after having this, it's divided by. then divided by, which is the same as using the ratio. So divided by, because sum of 8 is to sum of 4 can be given by sum of 8 divided by sum of 4. So we just need to know, or we can just say, okay, divided by sum of what? Of 4. So that is why we are now using this division sign. Now continuing, which means we are having a to the power ax r to the power of 4, because n is now 4, then minus 1 all divided by r minus 1. Good. So this thing is equal to just 97. You can say divided by what? Divided by 81. You can put the division sign, or you can write it in that ratio form. Now, after that, we know that this division thing can change to be multiplication, so that we simplify our thing. So what are we having? We have a is 2. We have r to the power of 8 minus 1, then all divided by r minus this. Then, which means times. When you multiply, which means you just interchange this thing. What was on top becomes on the bottom side. So which means now we're having r minus 1 divided by a into then r to the power of 4 minus 1. So this is what we have for now. Then this is equal to then 97 over 81. We're still doing following the ratio that was given. Now let's look at this closely. You can see that this can cancel that one, and also this a can goes with that a. Then you will be left with what? With r to the power of 8 minus 1 all divided by r to the power of 4, then minus 1 is equal to 97 divided by 81. So this is what we have so far. Looking at this kind of situation, we can simply factorize the numerator and the denominator if possible. Now let's continue by doing that. So how to factorize this one? You know that this is a difference of two squares. That is going to be r to the power of 4 minus 1. Then we have r to the power of 4 plus 1. Okay, then after factorizing, then you divide by r to the power of 4 minus 1, then all is equal to 97 over 81. Now you can see another cancellation is possible here. This and that, they are the same. Then we are now left with what? R to the power of 4, then plus 1, then is equal to 97 over 81. Then we can just be left with r to the power of 4. Then therefore we take this one to the other side. Then therefore we get this one is going to subtract that side. Then after subtracting, you will just get 16 over 81. Now we need now to apply the fourth root both sides. The fourth root both sides. This is plus or minus there. So which means our r is now going to be plus or minus 2 over. It's not going to be over 3. It's going to be 2 over 3. So we have that. Now you will realize or remember that it was given in the statement that the pattern or the terms that you are to find, they are all positive. So it's possibly that we are taking our r, which is 2 over 3, not the other one that is negative. Yeah, I believe so. But now the question says, let's find the first three terms. So now when you have a, which is equal to 9, this is what was given. So, and r is equal to, and r is that. So we can always find the first three terms. The first term is 9. Then the second term is going to be 9, then times 2 over 3. Well, then therefore, in simple, then 3 divided by 9 divided by 3 is 3. Then it's going to be 6. Then having 6, then the other one, you will be having 9 times r, then r squared, which is the third term. Then therefore, which is in simple, you are having 9 times 4 over 9, which is just going to be 4. Which is just going to be 4, which means you are having that one. So which means now we are having this kind of situation. This is the first term, this is the second term, this is the third term, and all of these terms are positive. So this is how we can approach this question, unless there is another way, or the easiest one, or the shortest one. But nonetheless, you can post it. If you have another idea of approaching this one, it's always open to receive views from your side. And thank you for watching, ladies and gentlemen. See you in the next question. Thank you. Let's look at this question together, and also be reminded that you are always free to try the question before you come for watching the solution. 2.5 reads as follows. Consider the geometric series, and you are having these three terms, these first three terms, and p must not be equal to 5. Now the question says, for which values of p, or for which value of p will the series be convergent? I think there should be values here, or value, but let's just go through the solution. So for which values or value of p will the series be convergent? So what do we remember about the word convergent? For the series to converge, it's whereby the value of r, which is the constant ratio, is between this interval. When r is between -1 and 1, then therefore the series converges. So we can call it the series is convergent. Otherwise, it is going to be divergent. Now, how do we go about starting to answer this question? We need to first find the value of r, because we understand for convergence, then therefore we need to follow this condition. So it's very important to know what is the value of r. Now, to find the value of r in a geometric series, we always say term 2 divided by term 1. So the term 2 value is this one. So we're going to say term 2, which is p minus 5, and it's being squared, divided by the first term, which is this one. The first term is 2, then p minus 5, just like that. This whole thing is just equal to r, because first term 2 divided by term 1 is equal to the ratio of a geometric series. Now, if we simplify this ratio, we are going to cancel things here, which means this one, there are two of them, they will be left with 1, then therefore this one is going to be cancelled. Yeah? Then we'll be left with only just 1p. Let me use this one. You'll be left with p minus 5 on top. Then below you'll be left with just 2. And this is equal to the value of r. So now we are forced to force this series that is given there to be convergent, which means this value of r is going to be in the place of r right between -1 and 1. Now we have p minus 5 divided by 2, which is less than 1 but greater than -1. Now we are in a position of finding the value of p using these inequalities. So for this one, we need to first destroy the denominator by multiplying each term by 2. By doing that, between there, you will be left with just p minus 5. Then on either side of the inequality, you'll be having 2 minus 1, which is just 2. Then on this side, you have negative 2 minus 1, which is negative 2. So on that note, we are interested in finding the value of p, so we need to transpose whatever that we don't want on either side of this inequality. So which means p on this side, 2 plus 5, which is going to be 7. Then this side, we have 5 minus 2 is equal to just 3. So these are the values of p that are going to make this series to converge, which means the ratio to be between -1 and 1. So on that note, we really need to be very careful when it comes to this, because now you can see that 5 is being omitted for, I don't know for which reason. So that now we can see that if we follow this condition, we need to break down our condition, that now p must be greater than 3, okay, and less than 5, because 5 must not be included. P must not be equal to 5. So which means p is greater than 3 but less than 5. And also the value of p also is going to be greater than 5 but less than 7. So I think this is what we have, so that our 5 becomes not included, because if we leave it this way, which means even 5 is within this interval. So now we'll begin to have a problem with that condition. So I think we really had to show this one. Otherwise, if there was no condition like that, there would be no problem for us to leave our statement here, our answer or our conclusion right there. So I think this was a tricky part, but I don't know why is it 3 marks, because for 3 marks there is a lot that we just did. But again, anyway, some of the things I shouldn't have shown them, but again, I have to, because of I really want to go with everyone in very same pace. So now let me just wrap this one and also answer the next question. The next question says, calculate the sum to infinity if p is equal to 4. But let's just remember that our r was equal to p minus 5 divided by 2. So if p is equal to 4 now, then our r, we have 4 minus 5 divided by 2, which is going to be 4 minus 5 is minus 1. Then therefore we have minus 1 over 2. So that means our r now is negative 1 over 3. So to find the sum to infinity, and sum to infinity is always found when the series is convergent. And because now we have r, which is negative 1 over 2, that means this r falls under that interval that we have written, which is less than 1 but greater than negative 1, because you know that r can never be equal to 1 or 0. Now, sum to infinity, let's just remember the formula for sum to infinity, which says that. Now, when you're looking for the sum to infinity, let's substitute by the value of a. But where to find a? A is this number, because we are given the value of p, which is p is equal to 4. So the value of a now is what? Is 2 into, then in the place of p, we put 4, then minus 5. Then this is just what we have. Then the value of a is going to be negative 1 times 2, which is negative 2. So on that note, sum to infinity is equal to negative 2, then divided by 1 minus negative 1 over 2, because in the place of r, I have to put that negative 2, negative half. Then therefore, we have that, which is 1 plus half. Then therefore you can press your calculator or work it out. It really doesn't matter. Then we have 1 plus 0.5. Then therefore the sum to infinity of this series is equal to negative 4 over 3. So this is what we have for this question, and I don't think there was anything difficult here. It's just a matter of the what you call the marks that do not tally with what we just did. But nonetheless, if we know that and we are confident of in what we just written, there is no problem. There is absolutely no problem. So see you in the next question. Thank you. All right, let's have this question. You can try it if you really want to. You can pause the video, then come back for the solution. So otherwise, we are having 3.2 here, which reached as follows. Consider the series, which is cos theta, then plus sine 2 theta. Then we have the third term there, where theta is an acute angle. Okay, so this is the series that we have. Then the question says, prove that this is a geometric series. For it to be a geometric series, it must give us the constant ratio, which means term 2 divided by term 1 must be equal to term 3 divided by term 2. So if we can just find the common ratio, then therefore this is going to be a geometric series. Now let's follow that that step. So term 2 here is what? Is 2 is sine 2 theta, then divided by term 1, which is cos theta. I would like us to first simplify this one alone, then therefore we'll come for the next one. So for this one, this is term 2 divided by term 1, and see what is it going to give us. Then we are having, this is the double angle of sine that can be expanded to sine x theta, then cos theta. Then all divided by what? All divided by cos theta. So this is what we have. So you can see that this cancel that one. Then the ratio is equal to, you can just say the ratio or the simplified answer here is just 2 sine theta. Let's check on the other side. What do we have? We have term 3 divided by term 2, then term 3 divided by term 2. So what do we get? So this is term 3, this is term 2, and see what are we going to get? Yes, so we have 4 sine 2 theta, then cos theta is divided by then sine 2 theta. So if we can simplify this one, you can see that we can just break this one down to say we have 2 times sine theta, then into, then therefore we are having 2 sine theta, then cos theta. It's like we removed a common factor, or we broke down this expression to be in a simplest form, because now we can see that the denominator has something to do with 2 sine theta cos theta. So you can see that this 4 comes from 2 times 2, which means we haven't changed anything here. We just broke things up so that we see the relationship between the numerator and the denominator. So now if we are to cancel out, we can see that this thing is the same as that one. Then therefore the solution becomes, so after that you can see that these two things are equal to each other. Then therefore you have this is equal to that one. So this ratio is now common. So it means that this is a geometric series that way. So if you get the common ratio, which is 2 sine theta, then you get 2 sine theta, then therefore this is geometric series, that one, because this ratio is common. Now moving to the next question. The next question, let me just clear things up. Hopefully we are not going to need this information that I'm clearing up. Now we are having this one. Calculate for which values of theta it will be, okay, calculate for which values of theta it will be a convergence series. So for this now series that we have seen, we have seen that it is a what? It's a geometric. Now for it to be convergent, for it to be convergent, how what is going to be the value of theta? So we really need to remember the first thing that we spoke about earlier on, that r must be between these two things. So since we have found out that r is 2 sine theta, which means this 2 sine theta must be between these inequalities. Then therefore we solve for what? We solve for theta. So having solved with theta, then we will know that we are going to have, let's divide by 2 both sides, or all the sides. Then therefore we're left with sine theta, which is less than 1 over 2, which is greater than negative 1 over 2. So we can see now that for this to be between these terms, so we are calculating the value of theta. So theta, let's say we have sine theta, which is less than 1 over 2. Then therefore we have theta, which is less than sine negative 1, which is the inverse of that. Then we get theta, which is greater than 30, is less than 30. Okay, then therefore we also have this one, which is sine theta, which is greater than what we have, greater than negative 1 over 2. So for sine to be greater than negative over 2, then therefore we have sine of negative, for the inverse of negative half, then our theta is going to be, we have that, then sine inverse of negative 1 over 2, 1 over 5, 1 over 2, then therefore it's negative theta. So which means now our theta must be less than, yes, remember here we are having greater than, yes, which means our theta must be greater than negative 30, which means we have negative 30 here, then therefore less than 30. So these are the values of theta that we have over there. Now we are done solving this 3.2. If you have any question or there is anything that is unclear to you, please rewind and listen it again, or you can post in the comment section if there's something that is not clear. I will then get back to you. Thank you. See you in the next question. Bye. All right, let's start at the question together. But if you really want to try it alone, you can pause the video and come up for the solution later. Otherwise, we are having this question 2.2 that reads as follows. The first 24 terms of an arithmetic series are 35, 42, 49, blah, 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 up to the last term, which is 196. Then the question says, calculate the sum of all the natural numbers from 35 to 196 that are not divisible by 7. So there's a lot of analysis that you need to go with here so that you don't miss the whole situation. So now you can see that these terms, the number of these terms is equal to 24. We have 24 terms, and you can see that all these terms are the multiples of 7. So which means now 35 divided by 7 is equal to a whole number, 42, 49, blah, 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 up to, let's check whether 196 is also the multiple of 7. Yes, because 196 divided by 7 is 128. So which means all these numbers are the multiples of 7, which means these numbers are divisible by 7. Now, calculate the sum of all natural numbers. Natural numbers are numbers that start from 1 up to the last number for this scenario. But calculate the sum of all natural numbers that are from 35 to 196 that are not divisible by 7. So the idea is to first find all the sum of all the natural numbers, which is now the natural numbers that we have here is natural numbers, the number of natural numbers that we have from 35. We just need to say, okay, 196 then minus 35. We are going to get a number, but remember that 35 is also included, but always just add 1, which means it's the same as to say 196 minus 34. So you will get what? You will get 162, which is the total number of natural numbers starting from 35 up to 196. So you have 162 natural numbers in this pattern starting from 35 to 196. So this is what we have. Moving forward, we can now calculate the sum of all natural numbers from 35, because we know the number of these terms, right? And we know that starting from 35 to 196, which means we have the first term and the last term, which is going to make things easy for us to use that sophisticated formula. Now, what are we having? We have sum of natural numbers. Let me just say sum of natural numbers is equal to, then we are going to have n over 2, then we have a plus l. So which means we have the first term, which is 35, and the last term is 196. So we can substitute now to find the sum of natural numbers. So sum of how many numbers? Of 162 numbers. Then it's going to be 162 divided by 2. Then therefore the value of a is the first term, which is 35. Then we put 35 there. Then therefore the value of l, which is the last term, is 196. Then therefore when you punch your calculator, you will of course get something like this, then plus 190 minus 96, then we have 18711. So this is the sum of all natural numbers, including those that are divisible by 7. But let's get the question now. Let's determine the sum of all natural numbers that are not divisible by what? By 7, which means now we need to subtract all the natural numbers that are divisible by 7, and those numbers that are divisible by 7 that you don't want in this sum are these ones that are given over there, because all these terms are divisible by 7 and you don't want them. So we need to remove the sum of them from this general sum that we got for all the numbers from 35 to 196, all the natural numbers from 35 to 196. This is the sum of them. So we need now to subtract the sum of all these numbers that are divisible by what? By 7. So which means now we know that all these numbers that are divided by 7, we are given the number of them, which is 24, which is half of something is done for us. Then therefore we can also use the very same formula that in the place of a we put 35, in the place of the last term we put 196, which means we are subtracting all these numbers that are divisible by 7, so to get the remaining sum, which are these numbers that are not divisible by 7. So we have 711, then minus, then we have into 24 over 2, then therefore we have 535 plus 196, then this is what we have. So the number that we got is 15939. So this is the sum of these of the numbers of all the natural numbers from 35 to 196 that are not divisible by what? By 7. Hence we have subtracted all the sum of numbers that are divisible by 7. We subtracted them from the lump sum, so we got the remaining, which is the net sum, which are the natural numbers that are not divisible by 7. So this is how we can approach these kind of questions. And if you enjoyed the video, you can like, comment and subscribe to my channel. And thank you for watching, and see you in the next question. Thank you. Bye. Okay, welcome to question number 3.1. We are having this question here, and I think these questions are repeating each other, but anyway, we are going to get more of confidence when it comes to answering these kinds of questions. So that is why I'm not running away from repeating them, because I see a need at times that some things, they really need to be emphasized using different types of questions that ask the same thing, so that you become familiar with what is being required in a question. So otherwise, we are having 3.1.1. I'm not going to be much deep in this one, because we just did something of this kind recently. Now, what are we having? We have term 1 and term 2 and term 3. So the first question says, for which values of x will this series converge? We know that for the series to converge, r must be between this range, this interval. So on that note, we need now to calculate the value of r immediately. So we have term 2, which is given by 3x plus 1, 3x plus 1, then all squared, then divided by term 1, which is 5 into 3x plus 1. So which means this is going to be your r, right? So this 5 cancel that one, and these 2 cancel the whole thing, because we have 2 of them in the numerator. Then therefore you will be left with just 3x plus 1, which is going to be your r. So your r now, for this series to converge, this r, which is 3x plus 1, must be between these inequalities, so that we find the value of x. This is how we find the value of x. Then therefore let's take this one to the other side. Then when we take it up, then we'll be having 3x, then therefore 1 minus 1 is just going to be 0, then negative 1 minus 1 is just going to be negative 2. Then we can divide by 3 both sides, then therefore we'll be having x, which is equal to 0 on that side, because 0 divided by 3 is just 0. Then therefore we have negative 2 over 3, which is negative 2 over 3. So these are the values of x that makes this series to converge, right? Then done. So let's come to this second question, which is always follows this question that is asked here. Then it says, calculate the sum to infinity of the series if x is equal to negative 1 over 6. So on that note, let's just quickly write our r aside. Then we have x plus 1 there. Then therefore let's just drop all these things that is unnecessary here. Then what are we having? We are having our numerical value of r, which is r is equal to, so then you have 3 in the place of x, we put negative 1 over 6, then therefore plus 1. Then therefore we have this and that, then we'll have to do that, just 2 there. Then we have minus 1 over 2, then plus 1, which is just going to be 1 over 2. So your r is 1 over 2. So on that note, we are going to write our sum to infinity formula, which is a over 1 minus r, which means if we have a over 1 minus r, we need to find what is the first term here, because a is the first term. So we have x, we have 5 into 3 in the place of x, we put just 1 over 6, then plus 1. Then therefore what are we having? We have 5 into just 1 over 2. Then therefore the answer is just going to be 5 over 2. So our a is just 5 over 2, then divided by 1 minus 1 over 2. So on that note, we'll be having sorry for this one. Then we have 5 over 2, then times 2 over 1, which is going to be just 5. The sum to infinity is just going to be 5. If this one cancels that one, we just have 5. So we are done with this one, ladies and gentlemen. Let's just quickly go to the next question. The next question is having sigma notation that we once dealt with, which means we won't be having any struggles answering it, but let's just continue doing it. Determine the smallest value of k for which this which is greater than 30 if k is an integer. So which means we are determining the value of k for which this is greater than 30, which means the sum of this is greater than 30. And if k is an integer, okay? Now, the idea is to, when you have this kind of thing, we need to have the first three terms. Remember what I said. First three terms is the key to approach questions with sigma notation. So which means now, if you don't see this one clearly, let me just write it in bold, just like that. Then we have k here, then we have 2, then p minus 4, which is greater than 30. Now let's find the first three terms. First three terms, in the place of p we just put 1. So we will be having negative 3 there, which is gonna be just what? Just 1 over 8, then therefore plus. Then when you put 2 here, you'll be having a negative 2, which is going to be just 1 over 2. Then therefore, when you put 3 here, you'll be just having 2 to the power of negative 1, which can be given, no, for that one, for which one? If you put 2 here, you will be having, you'll be having 4 here. Then if you put 3, you'll be having just 2. Then you can see that it continues that way. Okay. Now, you can see that your R now is equal to just 2. And you can see that this series is not convergent. It is rather divergent, because now you can see that R is equal to 2, which is not in the range, in the interval -1 is to +1. And you can even take your R right from there, because so this is what you have. Now we are looking for the sum for now. We're looking for the sum for now. Then what are we having? We have the sum of this arithmetic, of this geometric series, which is diverging, is what? Sum of this thing. Let's first write the formula, then Rn minus 1, then all divided by R minus 1. So which means now we do have this kind of thing. So having this one now, we can see that we are having the value of A is 1 over 8. Then into, then our R is 2, then our N is what we are looking for, right? Is what we are looking for, which means we are having K there, then in the place of N. Then what are we having? Then minus 1, then all divided by what? All divided by R minus 1, which is just 1. Let me just not complicate things, which is something which is not even there. So this is the sum, which is now greater than 30. So on that note, then after having this, you can multiply by 8 both sides to simplify the thing. Then therefore you'll be having this cancel this one. Then you have 2 to the power of k minus 1 is greater than, then 30 times 8 gives you 240. So after that, you will be having 2 to the power of k, then which is greater than 241. So I think for that one, we probably don't have anything that has to do with 241 and that. So which means we really need now to apply logarithms. Then logs are going to help us to say our k is equal to log base, which is 2, then the answer is 241. Then therefore we'll be having k being equal to, we can press our calculator now to say log base 2, then 241, then therefore we press our answer, then we get k, which is equal to 7,91 blah 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 blah. Okay, so and you can see that if we are having 7,9, which means now for this side to be greater than that side, or for this side to be greater than that side, which means our k must be equal to 8. Because we have to round off this one, because now if k is equal to 7 comma this, then therefore they are going to be equal to each other. But now if k is equal to or is greater than what we just got, then we're going to get the number which is greater than 240. Or if we go back to this one, then we're going to get the number which is greater than 30. So which means now our k in conclusion is going to be equal to 8. So this is what we have. So on that note, this is just a tricky question that needed deep of analysis and understanding of algebra at the most, and the nature of these series. Otherwise, see you in the next video.